Hello everyone. In this lecture we are going to discuss about the most important topic of this chapter, that is law of chemical equilibrium. Okay? Before understanding the theoretical aspect of law of equilibrium, just consider one equation guys. Consider a reaction guys. It says that AA plus BB gives CC and DD. As you can see, there are some small letters also, like these are the small letters A, B, C and D, and these are the capital letters, capital A, capital B, capital C and capital D. Okay, so this reaction says that AABB will initiate the reaction of CC and DD. Now let's understand this in simple terms. We also need to understand here that this capital this capital A and capital B, what are they? Guys, these are the reactants. These are reactants. And this capital C and capital D, these are the products of reactants. These are the products. A and B are the reactants. Capital A, capital B are the reactants. Capital C and capital D are the products. Now we need to understand that what is this small a, small b, small c and small d. Guys, these are known as, generally you call them as moles. You must have read about moles in the concept of molarity. And here these are moles only, but they are known by a technical name known as stoichiometric coefficients. So these are the small a, small b are the stoichiometric coefficients or the moles of reactants A and B, and small c and small d are the stoichiometric coefficients or moles of these products capital C and capital D. Okay, so whether you call about small a, small z, small b, small a, small b, small c and small d, all these are stoichiometric coefficients which you normally call as number of moles which are associated with reactants and number of moles which are associated with products. Okay, I hope this is simple, this is easy. Now we need to understand that what does this law says. This law says there are two things. Rate of, understand this guys, very important, rate of forward process which we generally denote as this. R is rate of and small f we write as forward process. So rate of forward process is directly proportional to, so this law says number one thing, rate of forward process is directly proportional to concentration of reactants. In the forward process, these are the reactants capital A and capital B. So concentration of reactants, which we write as bracket A into bracket B, raised to their power of their stoichiometric coefficients or as moles. And their stoichiometric coefficient was A was having small a and B was having small b. Okay. Guys, before proceeding further, let me tell you one thing. Usually in physics, you see square brackets, as suppose there was in physics, if we say A raised to power something like x, y, z, okay, or B raised to the power something, let's say PQR, some number like 2 is to 2 or something like that, or 2 is to minus 2, 2 raised to the power minus 2. In physics, I have written physical here, sorry. In physics, this bracket and raised to the power numbers indicates dimensions. Dimensions. But something you take in chemistry and there is raised to the power with that number, that is not considered as dimension, that is considered as concentration. Okay, don't forget this, that in chemistry, if some number is written as a raised to the power something like say xyz, then this is not dimension. This in chemistry is known as concentration. So you should remember this. Okay, this was one of the basic things which I need to tell you so that you do not commit any kind of blunder in the examination hall. Now guys, come back to this topic. If I need to find out the rate of forward process, okay, so in order to find out rate of forward process, I will take a constant known as kf. You have to use a constant kf. So it will be kf a to the power small a and b to the power small b, and we will take this thing as our equation 1. Similarly, if I need to find out rate of backward process, rate of backward process, so guys, it will be denoted as RB, rate of backward process, and this will also be directly proportional to the products. Earlier in the forward process, these were the reactants and these were the products. So they will be directly proportional to the products. And what are the products in the backward process? It is capital C raised to the power small c, capital D raised to the power small d. Okay. And now if I want to find out the backward process, so I will be using rate of backward process is equal to KB, because this time it is backward process. So it will be KB C raised to the power C and D raised to the power D. So from here I will consider this as my equation 2. Okay, I hope you are not getting confused. Guys, here this F indicated, this F in KF or RF indicated the forward process. This indicated the forward process. And here we are using B. This B indicates this backward process. Okay. Now guys, moving forward, we have just studied that if anything is at equilibrium, so we say that forward process, rate of forward process is always equal to rate of backward process. Now what was rate of forward process? This we have denoted as KF. This we have denoted as KF, capital A raised to the power A and capital B raised to the power B. It will become equal to KB, rate of backward process, which was C raised to the power C and D raised to the power D. Now guys, from this equation we can write this as KF upon KB is equal to C raised to the power C, D raised to the power small d, and A raised to the power small a, and B raised to the power small b. Now guys, as you can see that KF and KB are two types of constants. We can say them as two types of constants, and from these two types of constants we will get a new constant. we will get a new constant, and this new constant is known as Kc, also known as equilibrium constant. This Kc is also known as equilibrium constant. And guys, we are getting this new constant of Kc, which we are denoting as equilibrium constant, by dividing this constant of Kf and this constant of Kb. So by dividing constant Kf and Kb, we got a new constant known as Kc, which is known as equilibrium constant. Now what we have done is that we have replaced Kf divided by Kb and we have got Kc. Guys, remember that equilibrium constant is not written as Ke, we write it as Kc. So what will be the value of Kc? Its values will be similar, just like that of Kf divided by Kb. So Kc, equilibrium constant, will become capital C raised to the power C, capital D raised to the power D, capital A raised to the power small a, and capital B raised to the power small b. So this thing, what we are getting, is known as equilibrium constant. I hope you have understood everything correctly and have not got confused. And on this equilibrium constant, more than 80% of our chapter is based. And guys, also remember that law of chemical equilibrium is also known as law of active mass reaction. So law of chemical equilibrium is also known as law of active mass reaction. Guys, you have to note one thing, very important thing. When you are considering this equilibrium constant, while solving the equations and quotients of equilibrium constant, this I have told you in the earlier class also, but I am telling you in much greater detail, you have to ignore, you do not have to consider pure solids, avoid taking pure solids, as well as avoid taking pure liquids also. In equilibrium, in the study of equilibrium, we have to ignore pure solids and pure liquid. What you can consider is that, what you can take in your equations and quotients is that you can take aqueous mediums, you can take gases. This you can take. You can take aqueous, gases, solvents, and some reactions which have ions. Ions are always aqueous only. Aqueous medium contains ions. So you can consider this aqueous, gases, solvents, and any reactions which are having ions, but you have to avoid pure solids and pure liquids when you are considering Kc. Okay, that is equilibrium constant. So just in order to give you a wind up recalling capacity, so we have learned that rate of forward process is directly proportional to the concentration, their concentration of reactants, raised to the power their stoichiometric coefficients, which is known as you can also call them as raised to the number of moles. Okay, here A and B were the reactants, and similarly rate of backward process is also directly proportional to the concentration of the products raised to the power their stoichiometric coefficients, that is number of moles. And we know that at equilibrium condition, rate of forward process is always equal to rate of backward process. Okay, and this is written as, here we will take a constant Kf in the forward process, and in the backward process we have taken Kb. So Kf is capital A raised to the power small a, capital B raised to the power small b. And what is this backward process? Kb raised to the Kb, capital C in bracket raised to the power small c, capital D in bracket raised to the power small d. And if we will divide Kf upon Kb, that means here we are dividing C and D were the products. So we are basically dividing the concentration of products by the concentration of reactants. And since these were the two constants of different types, if we have divided constant Kf by constant Kb, we have got a new constant, and this new constant was Kc. I told you that always write Kc not Ke. Don't write Ke, it will become wrong. Equilibrium constant is known as Kc. So this Kc is the equilibrium constant, and it will have the same values: C raised to the power C, D raised to the power D, A raised to the power small a, B raised to the power small b. So again here you can say that in equilibrium constant you can see concentration of products are getting divided by concentration of reactants. Okay, so this is the basic law of chemical equation. And also remember, important thing that I've told you guys, you have to ignore taking pure solids and pure liquids. What you can consider is that you can take aqueous solutions, gases, solvents and ions are aqueous only, so you can take all of these. So thank you guys.